Spark Streaming gives you the capability to process live streaming data in small batches. Utilizing Spark's core, Spark Streaming is scalable, high throughput, and fault tolerant. You write streams program with D streams, which is a sequence of RDDs from a stream of data. There are various data sources that Spark Streaming receives from, including Kafka, Flume, HDFS, Kinesis, or Twitter. It pushes data out to HDFS, databases, or some sort of dashboard. Spark Streaming supports Scala, Java, and Python. Python was actually introduced with Spark 1.2. Python has all the transformations that Scala and Java have with dstreams, but it can only support text data types. Support for other sources such as Kafka and Flume will be available in future releases for Python. Here is a quick view of how Spark Streaming works. First, the input stream comes in to Spark Streaming. Then that data stream is broken up into batches of data that is fed into the Spark engine for processing. Once the data has been processed, it is sent out in batches. Spark Stream supports sliding window operations. In a windowed computation, every time the window slides over a source of dstream, the source RDDs that falls within the window are combined and operated upon to produce the resulting RDD. There are two parameters for a sliding window. The window length is the duration of the window, and the sliding interval is the interval in which the window operation is performed. Both of these must be multiples of the batch interval of the source dstream. In the diagram, the window length is 3 and the sliding interval is 2. To put it in a different perspective, say you wanted to generate word counts over the last 30 seconds of data every 10 seconds. To do this, you would apply the reduce by key in window operation on the pairs of dstreams of word, 1 pairs over the last 30 seconds of data. Here we have a simple example. We want to count the number of words coming in from the TCP socket. First and foremost, you must import the appropriate libraries. Then you will create the streaming context object. In it, you specify to use 2 threads with a batch interval of 1 second. Next, you create the dstream, which is a sequence of RDDs that listens to the TCP socket on the given hostname and port. Each record of the dstream is a line of text. You split up the lines into individual words using the flatmap function. The flatmap function is a one-of-many dstream operation that takes one line and creates a new dstream by generating multiple records. In our case, that will be the words on the line. Finally, with the words dstream, you can count the words by using the map and reduce model. Then you print out the results to the console. One thing to note is that when each element of the application is executed, the real processing doesn't actually happen yet. You have to explicitly tell it to start. Once the application begins, it will continue running until the computation terminates. The code snippet that you see here is from a full sample found in the network word count. To run the full example, you must first start up netcat, which is a small utility found in most Unix-like systems. This will act as a data source to give you the application streams of data to work with. Then, on a different terminal window, run the application using the command shown here.